Saman, you built Formic to accelerate adoption of automation in manufacturing. So, how about we start with a brief overview of the evolution of this field and what is its current state?
Yeah, absolutely. I think manufacturing is one of those really interesting industries because it's something we don't see every day in our daily lives, but it affects everybody in such profound ways, right? All of the food we eat, all of the stuff we buy, anything you see at a store, our cars, our planes, our kind of Wi-Fi, everything is ultimately built in a factory, and factories really have a wide range of variety. So it's very hard to generalize, but I'll say manufacturing in America in particular um, is pretty unique because most of American factories were built probably about 50 to 100 years ago. And during that period, there was this boom of industrialization, and that boom of industrialization led to a lot of the manufacturing sector all across the US. The interesting thing is, most of those factories in America are still kind of owned and run by the same families. Like most of them are family owned businesses that have been passed down a couple of generations. And the reality is a lot of those facilities look very similar to the way they did in 1950. And that means that they're generally very, very labor intensive places. And the reality is, like, the world around them has changed a lot. And so when it comes to automation specifically, 90% of factories in America don't have even a single robot on their floor. Not only that, they're also massively underutilized. So most factories in America only run about 2,000 hours per year. That's out of 8,700 possible production hours. That means every piece of equipment on that factory floor, every air conditioning, every square foot of space, every forklift, every truck sits idle 75% of the time. So as a result, the cost of their product is much higher, the cost of their operation is much higher, and it becomes very hard for these factories to compete with global manufacturing. And ultimately, this really, it doesn't come down to a shortage of demand. Right? All of our customers, all of these factories in America are 6 months or 8 months behind schedule on their production goals. And it doesn't come down to a lack of raw materials. Like there's not a shortage of steel or a shortage of aluminum or a shortage of you know farm goods to go and produce food products. Really, it just comes down to a shortage of labor. And that shortage of labor means that these factories are operating very, very suboptimally, and they're struggling to meet their production goals, and their cost of product is much higher. So, when we realized that that was the problem, we started to think really hard about what it would take to bring much, much more adoption of robotics to this industry. Not just one here or one there, but what's it going to take for us to deploy 1 million, 2 million robots in America? For context, right, there's 1.5 million unfilled manufacturing jobs in America today. And on top of that, there's only in last year, 2021, there were only about 35,000 robots that were deployed. So we're not even scratching the surface of this problem right now.
What are the reasons for that shortage of labor? Unlike many countries, the US is still growing population wise, and that would mean the new people are still being born and still being trained, but why the shortage?
I think it's just that there is a growth in population, but the growth of open jobs is faster than the growth of population ultimately.
Oh, I see. So it's just
And
a supply and demand.
It's a supply and demand issue. And also, the types of jobs we're talking about are probably like the first ones to empty, right? So most of our customers, a lot of these factories in America, they have 200 or 300% annual turnover. That means for every job, they have to hire 3 times a year. because these are very unpleasant jobs. A lot of the time, if you imagine, you're putting boxes from one place to another, you can do it, for 10 minutes a day or maybe an hour a day. But if you have to do it for 10 hours a day, 7 days a week, you much prefer to go work at Starbucks or somewhere else where the working environment is a little bit more comfortable. And so most manufacturing jobs are really fall into what we consider kind of dull, dirty, dangerous. At least kind of at the basic kind of operator level. There are a lot more creative jobs in manufacturing that people can do, but and with training, people are doing a lot more of that stuff, but you can't really move to those until you fill kind of the most basic roles of somebody who has to stand in front of this machine and load it and unload it, 10 hours a day. And so we're putting in a lot of robots that do that kind of work. And what that means is ultimately that the factories produce more, they're more prosperous, and all of the employees end up doing more complicated, more interesting, more creative work.
Gotcha. The 200% turnover is insane, for sure.
Yeah.
It's really
Yeah.
hard to operate a business with this type of dynamics.
Yeah. And many of them offer, signing bonuses of $2,000 or $3,000 just to hire a single, temp employee. And it's very, very difficult, even with that kind of a bonus.
You're right pointing out that it looks like we're behind the curve in terms of the adoption of robotic technologies. I looked at the World Robotics Report that just released, I think, a month ago. And, well, good news is we are deploying more, as a humanity, we are deploying more and more robots overall. I think this year we had a huge leap forward. About 35% more robots were deployed in 2021 than the year before. Few data points caught my attention there. One is the difference between China and US. China seems to be punching above its weight there. The difference is 7x, I think. So China installed more than half of all the robots installed in 21 versus 270,000 versus US 35. But when we look at the share of global manufacturing value added, China is bigger, but only 2 times bigger than the US. It's about 31% versus US 17. So I wonder why the disconnect.
Yeah, I think there's a couple of answers there. One is, I think American manufacturing typically right now tends to be some of the higher value goods. So things that are more expensive to produce and that have more margin into them. And the reason, truthfully, is those are the only kinds of things you can afford to make in America today. For kind of commodity, low margin, low value goods, it's very, very hard to justify manufacturing them in America right now. That's the main driver in that cost difference, though, is not, again, it's not that the raw materials are a different cost here. It's not that floor space costs less here. It's not that machinery costs less here. It's mostly just that labor costs, significantly more in America. So I think the US is, for now, still has a good amount of that kind of higher value good production, but it's starting to lose its edge. And without a significant adoption of robotics, it's going to be hard to sustain. China, on the other hand, is, I think, coming from a different place where they have spent the last 30 years or so with much lower cost of labor. And that lower cost of labor has allowed them to build a very, very large manufacturing and industrial base. And those economies of scale, for example, if you go to Shenzhen, for example, there are these giant kind of industrial markets where you can walk through and you can buy almost anything that you might need in a factory. You might need, a giant CNC machine, or you might need a bolt, or you might need a certain type of light bulb that's very specialized, or you might need a controller. All of those, you can just walk down the street and you can buy one and you can bring it back. In America, such a thing doesn't exist. This kind of idea of an industrial market doesn't exist. And so if I'm a factory that's in the middle of nowhere, in Kansas, and something breaks on my factory floor, my only option is to place an order with a distributor who buys something from the manufacturer, and then maybe it takes a week, maybe it takes 3 weeks, maybe it takes, in some cases, 12 weeks for that replacement part to arrive. And so you can just tell just by the way that these two industries are set up, like you just have totally different levels of operational efficiency because there's not the same level of density of manufacturing. I think China is using that advantage to help grow their manufacturing base. It makes it easier for them to adopt robotics, and they're taking a larger and larger share of global manufacturing supply. But I think that the same opportunity absolutely exists in America right now. And I think for a lot of big American companies, there's this urgent need to reshore manufacturing back to America. Things like the trade war, things like COVID, things like shipping costs, all inject a lot of uncertainty into the supply chain. And people are realizing that they have a lot more control over that supply chain if it's local. And so people are trying to find ways to bring manufacturing back to America.
Right. The cost of labor is definitely a huge factor there. The other data point that was interesting because of the cost of labor was the comparing US to, say, Korea. Korea is a quite developed country with quite high wages, and we have robot density there in manufacturing that is 4 times that of the US. So again, I was wondering, why did they manage to develop their robotics installations so much further than the US had?
Yeah, I think in both the case of China and Korea, one of the big factors is that the industrial base just happens to be newer, right? Like these factories were built 20 years ago instead of 80 years ago. And I think that difference means a lot ultimately when it comes to their ability to adopt new technology. I think factories that have been operating the same way for a long time tend to become relatively entrenched in the way of doing things and become a little bit resistant to change. Also, they have processes that are less amenable to kind of automation and robotics. In the kind of extreme case, right, in the US, one of the big adopters of robots is Amazon. And the reason that Amazon is able to adopt robots so quickly is because they're building new distribution centers every week. Right? And every time you build a new distribution center, you can build the distribution center around the robotics. And so they design the distribution center with robots in mind. And so adopting robots becomes a lot more straightforward. Whereas if you're trying to retrofit a 100-year-old facility, there's a lot more challenge. I think that is getting easier and easier as AI gets better. It means the robots are more flexible, more intelligent, and more able to work in these kind of more complicated environments. And so I think we're starting to get to the point where even these very old facilities now have the possibility to adopt automation.
So, talking about the US situation, you mentioned the legacy of 100 years old factories, maybe some inertia in terms of how the things have been done, more higher value added products that harder to use automation for. What are the other important challenges in implementing automation and robotics in manufacturing industry in the US?
Yeah, I think one big thing that's changed is that historically automation has been kind of the opposite of flexibility. What that means is, most factories have had to play this balancing game, where on the one side, they, for example, with a new product or with a new customer, they need to have flexibility in their manufacturing process. And then the mentality has traditionally been, once that manufacturing process becomes stable and it's repeatable and I'm doing the same thing over and over again, then I start to invest in automation. And that automation, kind of the more I invest in automation, the less flexibility I have. That's been the historical mindset and the historical approach. I think that's changing for a bunch of reasons. One, the technology is changing. So robots themselves are becoming more flexible. So historically, hard automation, traditional automation, you build it one time, it only works for one thing. Robotic automation is a lot more flexible, where you can reprogram the robot to do a large number of different kinds of tasks. So that's one big change. The second change is companies like mine, Formic, we we take on some of that challenge of flexibility as well. So instead of a factory having to spend $500,000 or $2 million on an automated case packer, for example, uh, we instead do that. Right? We will spend the money, we will buy and build the system, and then that customer can use it for 1 year, 5 years, whatever they need. And then once they're done and their needs change, we can take that robot and we can repurpose it into another factory. So this layer of kind of robot operators didn't exist before. You had to either spend $2 million or nothing, right? There was nothing in between. And I think about the example of the airline industry, right? Boeing and Airbus make fantastic airplanes, but 99.9% of people don't want to buy an airplane, right? It's not feasible. I can't afford it. I don't need an airplane sitting around all the time. And so this layer emerged of airlines, right? Like United, for example, and they say, I will buy the planes, I will manage the planes, I will service the planes, I'll maintain the planes, and you, Mr. Customer, just pay me for a ticket, and I'll get you from A to B. And when you're the customer, you don't care if you're flying on an Airbus A380 or a Boeing 747. Most people don't check, right? They're just like, does it leave this airport? Does it land in that airport? Okay, I'm there. So I think the same thing is happening in automation, where historically you had to be an expert at robots if you're a factory in order to adopt robots. Slowly that's changing, where companies like Formic are taking on that burden, and we say, hey, we are the experts at robots, so we will take on all of the challenges and complexity of managing and maintaining and deploying and installing that robot. We will have all the spare parts, we will do all the things that United Airlines does for their airplanes, but instead we will do that with robots, and we'll just charge an hourly rate for a factory to use that. And that makes their lives much, much better. And it allows us to invest in a bunch of technologies to make deploying robots much easier. And so we've built a bunch of software and tools and infrastructure that allow us to deploy a robot probably 70% faster and cheaper than industry norm.
What do you see the border between what you do, and what your customers should do? What is the most efficient way to split those responsibilities?
Yeah, I think we talk to our customers. Like our goal for our customers is to become kind of like a staffing agency for them, right? The same way that today they call a staffing agency and they say, I need a few people to do X, Y, and Z tasks. We want them to be able to call us and just make the exact same request, and we show up with a robot that does those things. And that means that we have to be very fast, very flexible, and very kind of efficient with our robot deployment, and we have to make it easy for them. The reality is we're not 100% of the way there yet. Right? We still need the customer somewhat involved in the process of installing a robot, but we're working to make it easier and easier and easier for them, to the point where it's literally just a phone call and we show up with the robot.
You got three components there: hardware, software, and financing platform. So talk about what each one includes.
Yeah. On the hardware side, we're a operationally heavy business. We have application engineers that show up at the factory and decide what kinds of robots we need to install. We have project managers that manage the build and deployment of those robots and installation. And then we have technicians and kind of production optimization team that manages post-installation the usage of that robot. Everything from spare parts to repairs to predictive maintenance and preventative maintenance and all the things that might happen to that robot. So we have a kind of operationally heavy team that manages all of the hardware related to that. The second part you mentioned is software. So we've built a bunch of software and tooling to make that first team much more efficient. For example, we have a tool that we've built that allows our engineers to walk onto the customer site, generate a 3D scan of that customer's facility, and then basically instantaneously simulate a wide variety of different robot variations, validate the right one for that application, and then generate mechanical prints, electrical prints, robot code, bill of materials, like kind of the full specs for what you need to solve that robot problem. And then we, hand that off to our teams that build and deploy those robots. So all of that is up, using software. And then we also, on the financing side, like you mentioned, we take on a lot of the kind of operational burden and complexity of deploying the robots. So we have set up about $250 million of debt facilities now, where we can use that capital to buy robots that we install in our customer's facility and charge by the hour for them. And so what that allows us to do is scale, very, very cash efficiently.
And you talk about a very competitive rates for robots, like an hourly rate of something like $10 or $20 an hour, correct?
That's right. Yeah.
Yeah, this is
Yeah.
this is very impressive. And in terms of the previous attempts, I think there were some companies that were trying to deploy robots and serve like a service providers.
Hmm.
But what did you learn from their experience? What do you do differently than they? I think taking on this financing part is definitely a huge step forward. What other interesting lessons you learned from a previous attempt to help manufacturers deploy robotics?
Yeah, I think there are a lot of companies that provide quote unquote robots as a service. I think what we've learned is that most of the people that do that do it on a specific piece of equipment. So, for example, I've developed a case packing robot, and you can buy it up front, or you can pay me a little by little over time. And what we realize is that doesn't really solve the problem at all, because for most customers, they still have to make the choice about what am I going to get? Is this the right thing for my factory or not? What about performance? What about maintenance? What about service? What about all these other things? What about if my needs change? What do you do with the robot in 3 years or 5 years? You're stuck with this thing that may or may not be a good fit for you. And so we have had to very deliberately say, we're actually hardware agnostic, right? We say we'll work with any kind of robot, whether it's Yaskawa or Fanuc or KUKA or Universal Robots, whether it's a complex case packer, or whether it's a simple palletizer, whether it's a welding robot. We kind of work with a wide variety of different things. And what we have to become good at is knowing the capabilities of all those robots very, very well, so that our customer doesn't have to. And so when they show up and they say, "Hey, I need you to pick up 10 of these bottles and put them on in this box," we have to be able to determine what's the best choice for that task. And we need to commit to the customer some kind of performance metric. So we don't tell the customer, "Oh, we're going to deliver this type of robot to you." What we commit to the customer is we're going to do 10 boxes per minute, and that's our commitment. And we have to figure out what we need to do in order to accomplish that. So it's kind of, we flip the approach a little bit on the customers, and we're not coming at it from an equipment first perspective, but it's a performance first perspective. And I think that's something that resonates much more with customers, because it makes their lives much easier.
Yeah, and it speaks to their real need versus to just something that you happen to have and want to sell.
That's
That's for
right.
sure.
Yeah.
In terms of your customer profile, how do you currently define it? How did it evolve, if at all, over time, and what do you see in the future?
Yeah. So our biggest customer segments right now are food and beverage manufacturing. So imagine a Willy Wonka's chocolate factory, that makes chocolate chip cookies or things like that. We have a bunch of customers that make all kinds of food and snacks and protein powder and matcha powder and things like that. So we put in robots that help load those things into boxes and put those boxes onto pallets, and put those pallets into trucks. So, the whole chain of things that need to happen on the packaging side. We also have a large number of customers in the warehouse space. So these are warehouses for logistics, similar types of tasks. We also have a good number of customers that are in the metal fabrication world. So they make parts for aircraft or for automotive, for aerospace, and these factories generally need robots that do things like loading and unloading a CNC machine or a press or a milling machine or a welding machine, or they need robots that do polishing or quality inspection. A lot of these factories have very, very high precision requirements. And so we have a lot of robots that do that kind of work. And then we also have a big segment around injection molding. So these are factories that make parts for example, a lawnmower or a golf cart or plastic cups. This injection molding process is also kind of a highly repetitive process that robots can help make much more efficient. So these products are in the world kind of all around us. In terms of the factories that we work with, it's very similar to the makeup of the typical kind of American factory. Most American factories are 2,000 employees or less. Probably the vast majority are 500 employees or less. That really is the majority of our customers. Is the smaller factories that have specialized and are really good at producing a few types of products.
Gotcha. And in terms of the equipment itself, you just mentioned the whole variety of equipment. So I maybe should ask, is there any type of robots that you do not cover currently and are in the roadmap for the future?
Yeah, one of the things that we have only recently started doing is mobile robots that move products around the facility. I think that there's some mature technologies there, but a lot of it is not yet at the level of reliability that we need. We also are, one thing, to be frank, is most of our robots today don't use any AI per se. I think that so my life before Formic, I was a venture capitalist for about 10 years, and I was investing in a lot of robotics companies and helping kind of brings a lot of these breakthroughs in AI to the real world, and I wanted to see them commercialized. I think they're fantastic technologies for a lot of environments, but for most factory environments, AI is still not ready because like most of these kind of AI models are probably somewhere on the order of 85% accuracy. Even if you play with Chat GPT today, you get a lot of amazing answers, but sometimes it's totally wrong. And that's fine for some use cases, especially if it's human augmented, where a person can be there to validate. But for a factory environment, that's just not sufficient. Right? Factories need 99.999% uptime. If you have 80% uptime, that means your robot stops working once per hour or twice per hour. And it's just completely impossible for a factory. And so we are very focused on technologies that work very, very reliably for now. I think we're looking for change, though. I think a lot of these AI technologies are maturing very, very quickly, and we will soon see the place where these things can be applied in the factory environment.
Yeah, I think I start seeing some things, especially in picking, where
Mm,
robots get more and more reliable on picking, and where we can measure the reliability now, not in 80s, but in 97, 98% ish. It still needs some help from human from time to time. And
yeah,
now human operators can remotely uh, operate that robot to fix whatever challenge it got itself into. But yeah,
that's right.
in
But even
general,
even even 98%, right? For example, in a factory environment, if you're picking boxes, you might do 15 or 20,000 boxes in a day. So 98% efficiency still means about a few hundred boxes that you pick wrong. It doesn't work for a factory environment, unfortunately. But yeah, I
yeah,
mean, I agree with you. I think we'll get there.
you're right. At the huge scales of manufacturing, you need reliability. And that is
Yeah.
points of the percent.
Yeah. Yeah.
What's your take on, or what's your approach to collaborative robots? They're growing fast. Again, based on the same report, they grew 50% year over year versus 30% for the traditional robots. Still very small, less than 10% of the all installed base, but growing rapidly.
Yeah, I think the line between collaborative and non-collaborative robots is becoming more blurred every day. Um, Traditional collaborative robots are very good because they allow humans to be near them and it's safe. And what that translates to for a factory environment usually actually means that it just is less floor space because you don't need a bunch of fencing and safety scanners and protections around the robot. And the robot can take up a lot smaller footprint and still get work done. The problem with most of the collaborative robots today is that they have issues around speed. So, by nature of being near humans, they generally have to work a little bit more slowly. And so, for some of these very high throughput environments, that speed is just not sufficient. And so it's good for some things, not good enough for other things. But we use a lot of collaborative robots for our in our customer facilities. Um, but there are also technologies that are kind of at the border between collaborative and industrial robots. For example, Veo Robotics is a company that I'm on the board of, and they've built a system that is safety certified, but allows you to use a very kind of traditional, heavy industrial robot. But they put some scanning systems, around the robot, and that allows the robot to work safely, even if there are humans nearby. And that's a huge breakthrough because it allows you to have the benefits of speed and reliability and weight, the payload capacity that these very traditional, very big industrial robots have. But you still can have the benefits of you don't need to build a safety system and you don't need to build a fencing around it and you don't need to cage it in. So I think we are starting to see, the borders between these two things start to slowly dissipate.
And the company you mentioned is also doing a great service to these traditional robots because we've invested so much effort into building them, and now with this small adjustment of setting up this monitoring system, we can dramatically expand the number of use cases, a number of environments where they can operate. So we can basically take what already works and just multiply it
That's right.
by some
Yeah.
multiple. Talk about some of your favorite success stories of you helping customers and what kind of impact it had on the companies you're working with.
Sure. Yeah. I think there's a lot of cool examples. One of my favorites is one of our first customers. This is a factory that literally used to make parts for the Ford Model T. So it's a very, very old automotive components
Wow.
factory. And the factory is kind of in the Chicago area, and they had a lot of equipment, but the direct words that the owner told me was, "We've been trying to automate for the last 10 years, and we haven't been able to do it." And he also said, if we don't automate, we're not going to survive. So it's this kind of catch-22, which on the one hand you have to do it, you're going to die if you don't. On the other hand, it's so difficult, so expensive, so complicated to do that most people can't do it. So when we came in, we put a robot in there. The first one we put was loading and unloading a press. It took this kind of metal bar, it put it in a press. The press would squish it, it would come out, and flip it around, put it back in, squish it again, and then put it into a box. So it's a pretty simple operation. But the first day that we installed that robot, the owner sat in front of that robot and watched it probably for 10 hours. He was just couldn't believe that it was working so reliably, and that all of a sudden, his plant, you could see he was starting to imagine all the other things that the robots can do. And so soon after that, we came in, we put in two more robots in this factory, and a few things happened which were really cool. One was um, the people started doing jobs that they preferred doing, right? Things that were a little bit more intelligent, managing inventory, people, managing the robots themselves. Maybe one person could manage 5 robots and five presses. So suddenly people were doing more interesting work. The second thing that happened was the capacity of that plant went up because they were only previously able to run maybe a few thousand parts a day. Now they could do 10,000, 20,000 parts a day. So their backlog started to shrink because they had all of these orders that they couldn't fulfill, and now they were meeting them. And then the third thing that happened that was even more exciting was that their profit margin went up significantly because they started running the robots for longer hours. Initially, what they did is basically, so they were working 10-hour days, but what they would do is right before they left at the end of the day, they would load up a bunch of parts for the robot, and then the robot would run for another 7 or 8 hours while everybody went home and slept. And so then they would come back and they would see, oh, we finished another batch of product. So they basically almost doubled their output. But the thing to remember is that there's not really any added cost, right? They have the same machinery, they have the same floor space, their rent hasn't gone up, they have the same forklift, all of their fixed costs are the same, but their top line suddenly doubled. And so what that means is actually the bottom line went up almost 5x because it's all the same cost, but you're now producing double the amount of product. And so that factory has kind of started to see a lot of kind of positive improvement. They're able to lower their prices and get more orders, and little by little, this factory is going from a trajectory that didn't look that great to a very, very healthy business.
This is a remarkable example, especially since they've been around for such a long time. You mentioned that they leave this robot to do the work during the night, so they just paying one additional worker or several additional worker payroll during those nights, hourly rates during those nights to you guys, right? And get all these benefits of increased productivity and throughput.
That's right. Yeah.
And
Yeah.
I wonder, how do you have to do a case to compare the costs of what would it take them to onboard a few more people to do the same amount of work versus what robots do, and how does it compare?
Yeah, I think that's a little bit of a moot question because most of these factories have been desperate to have more people for years, but they can't. Like they can't, either they can't find people, or they can't keep people, or they can't afford people. So um, it's really not even an alternative option. It's either they don't build that thing or they hire a robot. That's one. But in terms of the side by side cost comparison, I mean, obviously the robot ends up being cheaper than what they would have paid for labor. But we've heard many times from our customers, even if it's the same price as labor, I still want the robot because I can't find people to fill these empty headcounts.
That makes sense, and it looks like we're going to have more and more of those situations going forward. So it's about time we learn how to properly leverage robots in the manufacturing and beyond. Okay, let's talk a little bit about your personal journey. You mentioned you were investing in robotics and AI before running the global investment fund for Baidu Ventures. I wonder, what's the story behind it? Why did you decide to join that team? And what were the most important lessons learned from that experience?
Yeah. So I was a VC for about 10 years across a few different roles. Baidu Ventures was the last one that I was at. Before that, I was running my own fund and incubator called Comet Labs. And the truth for me was that I was a founder before. I started two companies and sold them, and wasn't really sure what I wanted to do next, and kind of became a VC almost by accident. I started working with one of my old investors, and they started helping me out, and I started looking at more and more projects. And really, what happened for me was that I saw what was happening in the world of kind of machine learning and deep learning, and I became a little bit obsessed. It became clear to me that um, computers were starting to get much, much better at understanding the physical world. Uh, and as they got better at understanding the physical world, they were also getting better at making decisions based on that understanding of the physical world. And they're also getting better at acting on those decisions, right? So, again, the sense, decision making, and action components all have started to get significantly better in the last 10 years. And so for me, my imagination kind of started running wild. And I thought, this can be used in so many ways. We need to see robots in agriculture, in construction, in manufacturing, in healthcare, in biotech, in recycling, and garbage. In all of these industries, there were so many opportunities for intelligence and robotics to come in and solve problems. So we invested in a lot of companies. Many of them were really, really fun, and I got to admire what these founders had built. But part of my brain was kind of always nagging me because I felt like adoption wasn't happening fast enough. On the one hand, I would look and see this new tool that could do all of these amazing things. And then on the other hand, I would see, they would sell maybe 5 per year or 10 per year, like very, very small, just not really solving the real problem of adoption. And that's really what led me to just to thinking more and more about Formic, because I realized uh, it's asking too much from the customer to have them, take on this risk of buying something, spending tens or hundreds of thousands of dollars to buy something that they don't know, that's new and relatively unproven, and then to also know how to keep it in use, right? To manage it, to maintain it, to service it. And so, because of all of that risk and cost and complexity, the easy answer for most people who needed robots was to wait. Everybody just said, "Oh, let's wait and see. Let's wait until it becomes more common." Um, so for me, that was really like the impetus. When I realized that was the problem, I started looking for analogies in other industries, and I realized like solar had a similar problem. AWS solved a similar problem for servers, and United, we already talked about as an example, it solved this for airlines. Right there's the need for somebody to say, I'm going to become the expert at this thing, and then I'm going to become the owner and operator and manager of these assets. And ultimately, that's what we're building here from.
And that chain of thoughts led you to start Formic. Curious, how did it work for you? Was it a very straightforward line, like, okay, you figured those ideas, now it's going to be Formic? Or were there some iterations that got you eventually to the current state?
Yeah, absolutely. It was a little bit more gradual process. When I realized that this was a problem, I started talking to a lot of people about it. I started to think about different ways that it can be approached. As a investor, one of the things I tried to do initially was to incubate a team to go and do this. I had incubated a few companies before, and I felt like if I could just find the right people, I can encourage them to go and start this business, and I can invest in it. And I looked and looked and looked and tried to find different types of backgrounds, different types of people, and just really struggled to find the right mix of experience. At the same time, as I've spent more time working on the problem, I realized this is a kind of once in a lifetime opportunity. I felt like we have the possibility here of building $100 billion company. It sounds a little bit ridiculous to say a number that big, but at the same time, it felt like there's not a lot of things that I've seen in my life as an investor that I thought this has the possibility of being $100 billion company. Many things I would look at and say, this has the possibility of being $1 billion company, or a $5 billion company, or a $10 billion company. But there's a much, much smaller subset of things that really can grow to that scale. And I felt like this was kind of a once in a lifetime opportunity for me to go and build this company.
Your comparison to AWS is a very good one, and it definitely shows that opportunity for the company of that scale. AWS have, I think, it a bit easier because all their assets are co-located in one place. so they can build the expertise and leverage that expertise and their huge scale, still working with those assets. In case of Formic, it's a bit harder because you need to
That's right.
deliver and monitor those assets. But I imagine you will rely a lot on the remote technologies to remotely manage and control your assets at your customers. Can you talk a little bit more
Yeah.
about that one?
No, you're absolutely right. I think it is harder for us to do what we're trying to accomplish. Well, the way that we're approaching that, like you said, is we're building a bunch of software to make diagnostics and remote error resolution more feasible. So we built tools that allow our engineers to see every sensor in the robot, exactly how it's performing, what's going on at every minute in time. We built software that looks for anomalies and takes those anomalies and responds very, very quickly and informs our engineers. We've also built tools, for example, like an AR visualization tool for our customers, so they can hold up their phone in front of the robot, and we can remotely point at different things, and we can say, hey, this component needs, can you wipe it down? The camera looks like it has something on it. Can you clean it off? And so we're creating more and more of these tools that allow us to solve problems. We have a command center where we have technicians and engineers that are watching all of the robots and managing everything. So all of that, it's an iterative process. Like you said, it's not kind of immediately solving all the problems. Our approach with this stuff is like, let's do it manually first. And then based on what we learn from doing it manually, we little by little build software to automate it and make it easier.
And now back to your journey. You said you incubated a few companies, and I wonder, what does it take to incubate a company? What's your recipe for doing that successfully?
Um, yeah, I think the obviously the main thing is the people, right? Like I think finding a group of people who are excited and capable to build a business is one part of it. The thing that I have realized is that it's much better to start from a problem than to start from a solution. So there are a lot of founders that have built a tool that does XYZ, and then they go around looking for who needs this tool. And I think that most of the time is very difficult to execute. What I tried to do when we were incubating companies was to spend a lot of time with users in different industries. For example, at Comet Labs, we had built what we call, like industry specific labs where we would bring 10, 20, 30 large corporations from that industry, and they would just talk about their business, right? Here's things where the efficiency is good. Here are the places where efficiency is low. If I had a magic wand, I would build a tool that does X or Y or Z, or here's what I wish, here's a tool I use that I don't like, whatever. I think asking a lot of those types of questions and collecting that data leads to a lot of insights about what works and what doesn't work in that industry. And then I think having capable founders who are excited about that problem space, listening to those will naturally give them ideas about different businesses they can start. And then once that happens, I think there's another aspect, which is knowing the technology, right? Like knowing what's possible. What are the things that weren't possible 2 or 3 years ago that are now are possible? I think being familiar with that, being up to date with all of the things that are happening in the academic world and the technology world, in the world of software and AI, allowed those founders to think about new ways of solving those problems. And so, yeah, it was really cool to see people come up with incredible ideas.
You mentioned that the source of ideas, or at least like context for ideas, came from those executives, the experts, subject matter experts, but the founders that now need to convert that into an actual product. What was for you the source of these people? How do you recruit them?
I think that it's really, um, different depending on the business area. But yeah, I mean, I think founders, I think have a couple of different characteristics. There's many different types of founders. It's hard to generalize. Some of our founders came from the world of academia. They said, they were experts in, for example, AI and machine learning and things like that. Some of the founders, I think, are generally, most of the founders that we worked with were relatively technical in their background, whether it's kind of engineers or academics or AI researchers or things like that. They were the ones who were most attuned to what was possible. But usually it's also a pretty special type of engineer that is also interested in the business side of things, right? Like a lot of engineers, my training is as an engineer as well. And I think in school as engineers, we're trained to, we're given a problem and then we have to solve it, and it's a very kind of direct response type of thing where you have an aircraft that's going at X speed and what's the trajectory or whatever, and that's not really how the world of business or startups works. You have to design the problem yourself. You have to invent different solutions. You have to look for shortcuts. What's the easiest way to solve this problem? And it's just very different usually from one of the quotes from Elon Musk that I really like is the best part is no part, right? And so as an engineer, your tendency is to say, oh, I'm going to solve this problem with this complex tool. And I think as a founder or somebody who's working on the business, your best bet is to find ways to eliminate the need, right? Like, what can I do to make this not even necessary? And so it just takes a slightly different mindset. But I think what's cool is that there's a lot of tooling now that has trained a new generation of founders. Places like Y Combinator have made a lot of the startup way of thinking so much more accessible to so many more people, and I think that's fantastic because now there's this new breed of founders the last 10 or 20 years that are really incredible.
I can't agree more. And in terms of that phrase, that quote, I believe there was a school of thought in Soviet Union called the theory of the solving of creative tasks. The
Mm,
theory created by Schuller in, I think, 60s or something. And that was one of the cornerstones of that school, that
really
the best
interesting.
way to do the thing is when the function is done but there is no part that is doing the function.
Mm,
One of the
mm-hmm,
examples he brought up, I remember, was that how they managed to figure out how to cover the steel in a cart. You need to transport the steel from the place where it was melted to another point. And yeah, it wasn't steel, it was some other matter, but doesn't matter. It was liquid. It had to stay hot. So, but you cannot put a lid on it because there were some technical issues with the lid. And if you don't put the
mm-hmm.
lid, it's gonna cool down. So
Cool.
what
Mm-hmm.
they figured out, they should use air to make a foam from the top layer of that substance,
Mm.
and the foam became a lid on itself. And when you
Cool.
pour that substance out of the cart, the substance melts, the foam melts the lid, so you're back to the melted state of the whole substance without having any lids there.
That's awesome.
Yeah, these guys were quite creative in their thinking. I think they,
That's really cool.
yeah, I think they're more popular in the ex Soviet Union or like that Eastern Europe part. Okay,
Yeah, there's a lot of incredible thinkers on this type of question. Yeah.
exactly, exactly. And yeah, that stuck with me. That idea stuck with me from the moment I learned about it, because I thought it's such a smart way to think about things. Instead of implementing or increasing complexity, you kind of try to reduce complexity, but still keep the function. Sometimes the function is performed even better than it would have been if there was a complex piece to
Some
address it.
some additional component. Yeah, absolutely. Yeah, that's
Okay,
cool.
so you talked about the importance of people for incubating a company. How did you approach bringing people to Formic? What kind of qualities you were looking for at the beginning? How maybe that changed? What kind of qualities you're looking for right now when you're bringing people in?
Yeah, I think my philosophy when it comes to hiring people is pretty simple. I look for people that are much better than me at whatever whatever needs to be done, and then I try to give them as much space and autonomy as possible to get that done. Um, I think there are a lot of qualities about the types of people that are um, appropriate for early stage startup that are different from a later stage company. I think some of them are more obvious than others, but in the beginning of a startup, people need to work very hard, and people who join the company need to be willing to do that. There's also a really important aspect of willingness to change and willingness to change their minds. And I find that that comes with humility. Right? I think people who have a certain amount of humility are able to learn, and based on new ideas, they're able to change their mind and get to kind of better decisions collectively. Um, so I look for that as a really important characteristic. Um, another quality that I think is really important is kind of self-directedness and drive. Right? I think people talk a lot about like management at a startup, but I think similar to the best part is no part idea, right? I think in a startup, a very early stage startup, the best management is no management, right? Like not no management, but like people who don't need to be managed are the best people. I think for a startup, people who can themselves figure out what are the best things to do. And I can say, for example, many of the people that we hired even before joining, put together a very complicated plan about here's what I want to do, here's what I need, here's what Formic is doing wrong, here's what I'm going to do when I come, here are the resources that I need, and they show up, with a bunch of ideas and plan ready to go. And I think that is a really good indicator because it means that they understand the task that's ahead of them. They understand the goal that they're trying to accomplish. And so I see my role as a CEO really mostly as being aligning people around the goal, giving people the resources that they need, and then helping to unblock, whatever comes in front of their way.
This idea of fighting bureaucracy with the bringing in right people, I think, yeah, Netflix is a known example of someone who advocates for this a lot. And yeah, that makes perfect sense in terms of that idea of no parties. Best part, having people who don't need to be managed is it's hard to overstress how much easier it is to run a company
Yeah.
that is built of
Especially
those
in a
people.
world that's remote, right? I think the last few years have made it so that we had to hire people in places that are kind of more spread out, and uh, it just means that a lot of the things that happen by osmosis when everybody's in the same room, they don't happen as much anymore. And what that requires is people who are much more self-directed and much more able to kind of set their own plan and be effective on their own and learn on their own.
Are you working remotely right now? What's your overall thinking on what's going to happen next to the remote work for you in general, for you personally? I mean, for Formic specifically, and for the world in general.
Yeah. So our approach right now is kind of a hybrid approach where some roles are remote and some roles are in person. Our reason for being remote is a little different than other companies. It's not so much the pandemic anymore, but it's mostly because our customers are spread out. So we have um, a hub in Chicago, we have a hub in North Carolina. We're starting to set up a hub in Texas. We're going to soon set up a hub in um, New Jersey to serve the East Coast. But basically, the manufacturing sector in America is spread across a lot of different geographies, and we have to have a kind of physical presence in most of those places. And so, in each place that we set up a new hub, we start with hiring a few uh, sales engineers, a few salespeople, and a few technicians, and then we build a hub around that. And then so some of those functions are more central or decentralized. Some of the functions are more centralized. For example, things like finance and legal and um, kind of maintenance operations and project management and things like that. These are roles where we have a little bit more flexibility in our geography. So It's been a challenge for sure in terms of setting up the way that we build this team, but it's been kind of a mixed approach.
And now it's clear why it should be a mixed approach. It can, yeah, the luxury of having old people in one room is not maybe the case for Formic, and it's getting harder and harder for each other company. The competition for talent is still significant even after the layoffs and everything, especially if
Yeah,
you're like, not based in some of the areas where you have an abundant access to talent.
yeah. I mean, we definitely love the idea of having people together and in the same room. Just because of the fact that our customers are so spread out, it's very difficult to accomplish. And so, yeah, we've taken this kind of hybrid approach. We're centralizing more and more. I think as we get bigger, we'll have more critical mass in each place, and so we'll still get some of the benefits of that. We also do a lot of offsites so that we can spend time together in person. I think there's a lot that can be accomplished in person that you can accomplish purely remotely. So, for example, I think we do a full company offsite right now about twice a year. We're about 60 people now, so that's a pretty big gathering. And then the leadership team gets together, usually about once a month. And then also the each department also gets together more or less frequently depending on what they need. So it's it's a kind of mixed approach right now.
Get you. Where did you go for your last all hands retreat?
We went actually to upstate New York near the Catskills. There's a really cool place that we were able to get a bunch of trailers, basically like kind of Airstream RVs in a row, and everybody kind of got their own space, but we were able to gather. So it's definitely a balance of finding a cheap way to get everybody together. As a startup, we can't spend that much money.
Abs- Absolutely cheap, but still very fun way.
Yeah, exactly. Yeah.
Okay, let's turn to the future now. How do you see the robotics adoption evolve over the next 10 years globally and here in the US? And how will the robotic systems change? And ultimately, what's your vision for Formic?
Yeah, I think like we talked a little bit about AI and its impact on robots. I think that's one of the things that's most exciting for me right now. We're starting to get to a world where AI is actually able to solve a larger number of problems. Uh, I think the things that are leading to that are much better sensors. There's people are building for example solid state lidar. People are building new types of millimeter wave radar and things like that. New vision systems, much lower cost cameras. All of these things are basically kind of broadening the set of tasks that robots can do well. There's also a lot of new compute, new processing power, types of kind of ASICs that are allowing basically computer perception of the physical world to get cheaper and more efficient, more real time. Then on the algorithmic side, there's a lot of improvements happening. Reinforcement learning is one of the examples, but there are a lot of interesting things that people are doing that allow computers to get better even in a simulated environment. And then the robot hardware is also becoming significantly cheaper. A lot of it is due to kind of explosion of smartphones in the last 10 years. That's brought the cost of sensors and compute and vision systems and kind of a lot of the manufacturing capabilities that went into the mobile supply chain are actually being now applied to robotics. And so I think we're going to see the cost of robot arms drop significantly. We're going to see the cost of a lot of the other components around robots drop significantly, and just going to make robots more and more accessible to more places. So I think we're kind of at the beginning of this precipice of of change. In terms of my vision for Formic, I think it's very related to that. I mean, ultimately, it sounds kind of simple, but the goal is really to just put robots in as many places as possible. I think humanity needs many, 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 many more robots. Not to become too philosophical about it, but I think a lot about kind of agriculture as a shift in human society, right? Where there was a long period of time where most humans in the world spent most of their time on subsistence. Right? It was just like, how can I grow enough food and feed myself and my family? And that was all that people did. And it wasn't until the emergence of agriculture that it became possible for a smaller group of people to produce enough food for the tribe or the town or the city, and that then allows for all the other people to start doing more high value things, thinking about systems of government and organization, thinking about art and science, and all of these things. And as that happens, we start to see human civilization kind of flourish. And so, on the same note, I think we have this kind of an opportunity for humanity today, where even though kind of where a lot of people in the world are fed, still there's a large proportion of society that just doesn't have access to all of the things that they need. And by kind of drastically increasing the means of production, suddenly we will see kind of, I think, another flourishing of human society.
When we talked before, you mentioned creating a world of abundance as an ultimate goal. I really like
Yeah.
that way of looking at robotics overall, and it is. The thing we'll have to solve there, I guess, is our energy, because for the agriculture to really become what it became right now, when only, I think, 2% of the US population is involved in agriculture, and they manage to feed the US overall and export some. The real game changing thing there was access to hydrocarbons that we can extract from Earth. And the next step change there will likely need a little bit of a boost in our energy available to us to power all those machines. But then I don't see any reason why we can't have a much more abundant future powered by a lot of robots for those tasks that you called dull, dirty, dangerous, and then people do more of a creative side of things.
Yeah, and I think related to that is the fact that, I mean, if you think about, even just take energy as an example, right? Like nuclear energy, like, nuclear fusion. How many people in the world today are actually working on nuclear fusion? Maybe 10,000, maybe 20, 20, 30,000. Like, it's not much more than that, right? Out of our 8 billion population, why are we dedicating such a small proportion of our society to making progress on nuclear fusion? Or the same thing can go for any area of academic research. Right? And I think a lot of it comes down to most people just spend all of their time producing stuff, right? Like whether it's working at a grocery store or working on a construction site or working in a factory, the vast majority of humanity is still occupied with just keeping the lights on, basically, right? And I think if we make it possible for there to be so much abundance that we actually can free up humanity to do these higher order things, why not have 10 million people, or 50 million people working on nuclear fusion? Why not have 50 million people working on new systems of government? Like, we should have, as humanity, like, we have the capacity, we have the capability, we have creativity, we have all these people with all these skills and abilities, and instead they're spent on doing menial tasks. So obviously that puts a big demand on the education system and other things, but I think that we're at the beginnings of a shift in the way that human society should be organized.
Yeah, and I think even without changes to education, although those will have to be done, the menial tasks currently consume some of those bright minds that would have
Absolutely.
went on their own without any changes to other systems and just contributed to engineering and science, but instead have to work hard every day to just say provide for their families because they're in such situation overall.
Mm-hmm.
So this is an exciting future to look forward to. Where can listeners learn more about the company? Where can they follow you all on social media? And I also know Formic is still hiring. So talk about the position you're hiring for.
Absolutely, yeah. We're very much looking for engineers of all sorts, robotics engineers, software engineers, web developers, front end, back end. We're looking for engineers of all sorts. We're also looking for a wide variety of different roles. You can find them all on www.formic.co. Our Twitter's Go Formic. We're always looking for people there. That's how we kind of interact with a lot of our friends in the wider world. And then also, if anybody knows of any factories that are looking to kind of grow their productivity and are looking to expand their capacity, we're always more than happy to put some robots in.
Excellent. Saman, thanks a lot for joining me today. We'll put all those links into the show notes. And it was a great pleasure to talk to you.
Thank you, Artem. Really enjoyed the conversation.